Let's now actually begin to write methods that operate over arrays. So in this example, we're going to write a method that returns the maximum number in an array of integers. Okay, so you may be wondering, well, what do we do in the case of an empty array? Well, there's two answers to that. One is we could just not test that, or we could say that the minimum is some really small value. Okay, so the integer limit in Java is -2 to the 31st. So what we can do is just say that if there's nothing in the array, then that's just synonymous with the smallest possible integer value. Okay, because we can reasonably assume that the inputs to these lists will not be this really small value, so it's okay to say that this is the minimum. So some people may accidentally say, why not make it -1? Well, the problem is that negative numbers can be inputs to the array. Okay, so we can't just make it -1. I mean, it's -1 in this case because that's the largest number, but in general we can't do that. Okay, so we're gonna write. So generally, when you're writing arrays, methods that operate over arrays, you're not gonna make them recursive. Okay, that's just not something that you do. And what's worse is that you can't slice an array. So we're gonna have to make a helper method for the standard recursive method that receives the index of interest rather than just recursing over the array itself until it's empty. Okay, so how are we going to do this? So how are we going to write a method that recursively finds the largest number? Well, so we first immediately need to make a helper method. So we're going to do that. Let's do return max number helper a and 0. Okay, so the 0 is going to be the index that we're checking, just like we would if we were writing a method that recurses over a string. But instead of recursing over the string, we're recursing over the index. Okay, so private static int max number helper is going to receive the array and then the index that is effectively our accumulator. Okay, so the first thing we need to do is have a case analysis to say when we've gone out of the bounds of an array. So just like we would with a string, we're going to check to see if I has exceeded the length of the, or is equal to the length of the array. And if so, we'll return our default value, which is integer.minValue. Okay? Now, what about when it's not empty? Well, there's a couple ways that we can handle this. So what we know about the maximum number of an array is that we know that, let's say we have like 3, 12, 81, 0, and -8. Okay? So we know that the maximum is the max of the first thing in the list, and then recursing on everything other than the first. Okay? So you may wonder, well, how are we going to do that without like slicing or without like a subarray method? Well, we know that when we get down to the empty array, or when our index is way out here, then we're going to return the smallest possible value, which is effectively -infinity for our purposes. Okay? So then we're going to be computing the max of, let's say, -8. Let me draw that correctly. -8 and -infinity. That, of course, is -8. So then we're going to recurse. So this is when we're unwinding the call stack. We're going to get the maximum of 0 and -8, which is, of course, just 0. Then we're going to get the max of 81 and 0, which, of course, is 81. Then we're going to get the max of, let's see, it was 12 and 81, which is just 81 again. And then we're going to take the max of 3 and 81, which is 81. Okay? So the outer operation is going to be a call to math.max. Okay? So we're going to do return the maximum of what? It's going to be the first thing, or the ith thing, and then we're going to make a recursive call by just passing a and then incrementing I by 1. Okay? So again, draw the stack trace if this doesn't make sense to you. But this would be, this is probably the simplest way to do this in one line. And I really think that this is a good way to write the method, okay? Because it's standard recursive because the outermost thing is a call to math.max. And yeah, so let's run the tests. For some reason, this again is just doesn't have the green check mark here. But as we can see, all tests pass for the standard recursive version. Alright, so now we're going to convert this into a tail recursive method. So let's do that. So we know that we're going to have a helper method again, so return max number tr helper. We're going to pass the array, the index, and now we're going to pass the accumulator that keeps track of the maximum value seen so far. So we'll come back to that, but now let's just copy the entire thing that we have up here, add tr to it, and then we're going to do something here, and then we're going to do something here that is a tail recursive call. So we had better do that. Okay? So a stays the same, the increment to I, of course, is there, but now we need to know what are we going to do with ACC. Well, we know that it should be the maximum of the first thing, or the ith thing in the array, and ACC, okay? Because with each call to the tail recursive method, we're going to say, is the maximum the thing that we're looking at now, or was it the thing that we've looked at before? Okay, and the ACC represents, the accumulator represents the thing that we've looked at previously. Okay, so we'll do math.max, a at I, and ACC. Okay, so tr helper, there we go. And then for here, of course, what do? Well, if there's nothing in the list, then, or if there's nothing in the array, then we want this to return integer.min value, which makes sense. So we know that our method is going to return the accumulator, and the smallest thing by default is going to be integer.min value. Okay? And those are just the principles that we learned about when writing standard recursive methods and then writing tail recursive counterparts. Okay? The starting value for the accumulator is likely just the thing that you return in the base case of the standard recursive version. Okay? Now, we have the loop version. So, we're going to do two versions of this. We're going to do the translation pipeline, which still works, and then we're going to do the more idiomatic way of solving this problem. Okay? So let's rerun the test just to make sure that they pass. They do. Okay? So, let's follow the translation pipeline. So, we're going to take our accumulators. Well, if this were on paper, we would identify the three components, but since this is code, we're just going to go straight into step 2. So we'll do int I equals 0, int acc equals integer.min value, because those are the values that we start off with in the driver. Then we're going to have a loop, so while it's not the case that I is greater than or equal to a.length, we're going to do what? We're going to say that I is equal to I plus 1, and then ACC is equal to math.max of A of I and ACC. Okay, but notice that we're violating the rule of update here, because remember that since this parameter, this argument depends on I, we have to update ACC first. So let's do that. And now we're going to return our accumulator. Okay, so all tests should pass, and they do. Now, this is great and all, but again, we want the whole reason that I exists is to interface with the array, right? It's what we use to index into the array. So we can get rid of that, and we can localize it to just this loop by using what? By using a for loop. So let's get rid of the I, let's get rid of the I plus 1, I equals I plus 1, let's translate this into a for loop. So we're going to do for int I is equal to 0, and then what are the bounds of being an array, or being in an array? Well, we know that it's, of course, between 0 and the length minus 1. So just like with strings, we can do I is less than a.length, and then I++. And then this line actually stays the same, because we still want to compare whether the thing that we've seen before, or the thing that we're currently looking at, is greater than the thing that we've looked at previously. Okay? Now there are ways of writing this as a separate condition, like doing an if a at I, so something like if a at I is greater than ACC, then ACC equals a at I, and otherwise it stays the same. But I think it's better to just wrap it all in one line with a call to math.max. But you could have easily written all three of these without using math.max, and it would have worked the same. Okay, so let's run this, and the test should still pass, and they do.